Hello and welcome. This is 10.3 Geometric Sequences and Series, where we're going to define what a geometric sequence is first to start things off. I kind of alluded to this in the last couple sections, especially this one, where two, we learned arithmetic where we're adding and subtracting a term each time. In this one, it's a ratio, meaning we're going to be multiplying or dividing by a number each time. I prefer talking multiplication because that's how the formula is going to be set up more so. Geometric sequence is a sequence where the ratio between successive terms is constant. So you're multiplying by that same term each time. And that constant that you're multiplying by is the constant term of the geometric sequence. Okay, so whatever that ratio is, we try to find it. We make sure that there is one before we do it. Now, let's determine the common ratio here. Now, how I like to do it is do a quick 11 over 4, 30.2 over 30.25 over 11. If they all equal each other, it's going to be a ratio. It's going to be whatever that is. And in this case, 2.57, 2.75 rather. Apologies. So what will the next four terms be? We're going to keep multiplying by 2.75 each time. And when we do that, we're going to get 83. I'm going to round two decimal places to make life easier. 19,228.77. Then it's going to be 62911. There you go. Those are your next three terms. Let's see this one over here. What's happening? Is it going to be the same each time? Negative 16r plus 32 over 64r minus 128. 4r minus 8 over negative 16r plus 32. Yes, because you're going to be multiplied by negative 1/4 each time to get from, because if I were to simplify both the numerator and denominator, it would be negative 1/4 would be the common, what you would get. So if I am multiplied by negative 1/4 each time, well, let me say r is negative 1/4. I should label that over here. R is 5 in the last problem. So the next couple terms, I'm multiplying by negative 1/4 each time. I'm going to get r plus 2, negative r plus 2 rather, and then I'm going to get r over 4 minus 1/2, and then negative r over 16 plus 1 over 8. So just keep dividing by or multiplying by negative 1/4 each time. So we are going to write the explicit formula and recursive formula. Now they look a little bit similar to what we did in class for arithmetic. It's going to be a sub 1 times r to the n minus 1 power for your explicit over here on the left. For recursive, you need to write what a sub 1 is and then tell me what r is, and then it's going to be a sub n minus 1, a sub n. So let's do it. Let's go to solving. 25 over 2 and 312.5 over 25, it's going to get you the same value. And that value is going to be 12.5. So 12.5 is going to be your R. Okay, to the n minus 1. What's your a sub 1? It's 2. There you go. And then over here for your recursive, a sub 1 is 2. And we just said what R is. There you go. Find the specific term of each geometric sequence with the given characteristics. So we want to find a sub 9 for 4, 14, 49. So 14 over 4, 49 over 14. Those two are equal to each other and get about 3.5. There you go. That's good. So since we've got 3.5, what we're going to do for R, and ace of 1's 4. So what's n going to be? N's going to be 9 because it's the ninth term. We know, and I put 4 here because we know that 4 is your ace of 1. So if I put, what do you say it was 9? Yes. That was a 9, not an A, just so we're clear. If you get that, it will equal about 90,000. Yes. 90,075.02. Now, we want to find a 12th term if a sub 3 is 32 and r is equal to -4. Well, that's a little helpful. So what we're going to do is we're going to temporarily treat a sub 3 as our a sub 1. Okay, so we're going to make that 32 times 4 to the n minus 1 power equals a sub n. Now, keep in mind, as I said, 32 is not your a sub 1. I did not change that, but in order to find a sub, in order to find that, I'm going to plug that in temporarily to find a little bit more information. Because if we do it this way, I can find what the 12th term is. But I'm not putting in 12 in for n either. How many terms have passed? So if 3 is our new 1, that means it's going to take 10 terms in order to get to a sub 12. I know it's tempting to say it's the difference is 9, it's our ninth term, but it's not. It's a 10th term. Think of it this way: we push it up 2 spots, right? So if we push it up 2 spots, this is essentially going to be 10, not 12, because it's 2 away. So I put 10 in for n times 32. And when you do all this, what is it that you get? A really big number. Oh, I forgot. This should have been -4 for your R. My bad. And what is that really big number? -8,388,608. All right. So find the indicated geometric means for each pair of non-consecutive terms. So there's 2 means in between -4 and 13.5. So that means we're going to call this our first term and this one our fourth. Okay. So if we do it that way, let's go to our explicit formula and make it A4 equals A1 r to the n minus 1 power. We'll make that -4. We'll make this 13.5 rather. And it's going to be r to the power of 4 minus 1 because it's the fourth term. So if I divide both sides by -4, I'm going to get 13.5 over -4 equals r to the third. Cube root both sides. Go ahead and calculate and cube root that. And what would you get? You will get -1.5 is your r. So if I multiply -4 by -1.5, you're going to get 6, and then you're going to get -9. Oh, nice. Try this one on your own. We'll go over it when you come to class. Okay? Hopefully you have it done correct. 3 means. Similar to the sums for your arithmetic mean, here are your sums for your geometric series. Those are your formulas. Go ahead and jot those down. Find the sum of the first 11 terms of the geometric series. 7 plus -24.5 plus 85.75, and keep going. So first we need to find our r. We cannot do this without our r. We do have a first term, which is cool. We like that. We'd love to see it. But I don't know my r. So -24.5 over 7 and 85.75 over -24.5. Those should be the same thing. Hopefully they are. I'm going to check. And the r, it's negative 3.5. So your r is negative 3.5. So when I use the formula, I'm going to use the first one. S of n equals, what's the first? 7. Parenthesis. That's an ugly parenthesis. Let me fix that, shall we? 7. We got 1 plus negative 3.5 to the power of what? What's n? It's the 11th term, so I'm going to make 11 over 1 minus negative 3.5. I'm sorry, this should be minus right here as well. And when you plug that in, what do we get? A really big number once again. It's going to be about 1,501,877.34. Another one, another sum problem. We have all this lovely information here. I got a sub 1, always needed. Got a sub n, also needed. And we got r is equal to negative 4. So let's solve. What else am I going to need? I'm going to need to figure out what n actually was. So we're going to go back to the explicit formula in order to find out what n is. So let's write it down. There it is. A sub 1 is negative 8. A sub n is 131,072. And r is negative 4. I don't know what n is. Divide both sides by negative 8. And that will get me negative 16,384. And then, so what value would n have to be? And I just realized I had an easier way of doing it, so we're going to stop this nonsense right now. I should have done a second formula. Silly me. I'm sorry. You wrote all that. My apologies. Let's do it the easier way. A sub 1, negative 8, minus 131,072 times r, which is negative 4, over 1 minus a negative 4, so 1 plus 4. So you will get, throw that all in, you get 104,856. And here we got a geometric sum with sequence notation. So our r in this case is 0.5, right? So when we go to use our formula, we're going to have that over that. Now, what is our n? Whenever, just like we did in arithmetic, we subtract and then add 1. So it's going to be 8 to the power of 8. What is your a1 in this case? It's whatever, since it's 4 on the bottom, if we put 4 into here, that will be, whatever that output is, will be our first term. And when you do that, you get 15. So whatever that gets you will be your partial sum, which gets you approximately 29.88. Now, if we have a sum of infinite geometric series, we use this formula right here, S equals a sub 1 over 1 minus r. Okay, so let's do some examples. So we got right here, what's the ratio from here to here and here to here? It's going to be negative 0.5. Your r is negative 0.5. Your first term is 10, right? So when we go to do this, it'll be 10 over 1 minus negative 0.5. What will we get? That will get us 10 over 3 over 2. Flip it. You will get an answer of 20 over 3. This one right here, 15 over 20, 10 over 15 are not the same, so we can't do this one. This is not a geometric sequence. No, not a geometric sequence. Okay? that's why we check that, just to make sure it is. Okay. So here we got n equal to 1 all the way to infinity. We have an r of 0.8, so I'm going to put that on the bottom. Your first term, when you put 1 in for n, you'll get 20. So you get 120 over 0.2, which will get you 600 for the answer. Awesome. Thank you for watching, and we'll see you next time. Toodaloo.